One of the methods that we can use to solve a system of linear equations is called elimination. And this is my personal favorite because it's really just adding or subtracting something from each other. You'll see. Let's start a question. So let's say I would like you to solve the system of equations. For x plus 3y equals 5 and negative 4x plus 10y equals 34. Now, we could definitely solve this graphically, and we could solve it by another method called substitution. But this time, in this video, we're going to use elimination. And elimination is exactly what it sounds like. You're getting rid of something. Excuse the background sound. Okay, cool. All right, you're getting rid of something. So you want to look at your equation. You want to think about what could be really easy to get rid of. And here's how you decide. If you have something that's extremely similar to something else, that's probably a hint that it's going to be really easy to eliminate it. So, for example, off to the side here, if I had 4x and I added negative 4x to it, what's going to happen to our 4x? It's going to be eliminated. It's going to be gone. All right, so what that means is I can actually, believe it or not, take one equation and add the other equation to it and eliminate something here. So I'm going to add my equations to each other. So let's see. I just erased something. Let's put that back. There we go. All right, so I am going to add my first equation to my second equation, just because I want to eliminate that 4x. So when I add 4x to negative 4x, as we spoke about, it goes away. But I can't just add my x's and then keep it moving. I have to add each and everything. So when I add my other set of like terms, my 3y to my 10y, I get 13y. And I have to also add my constants to each other. Those are like terms as well. So when I add my 34 to my 5, I get 39. So now I have a very simple looking equation, and I'm trying to solve for y. So all I have to do at this point is divide both sides by 13. And I get that y is equal to 3. But I'm not done, because there were two variables in this equation, a y and an x. At this point, I can choose either equation. So let's call that equation number 1, and let's call that equation number 2. And I can choose either equation. And I like small numbers because I like to keep things simple, so I'm going to choose equation 1. And over here, 4x plus 3y equals 5. I'm just rewriting our equation. And I'm going to plug in my y and see what x would be. All right, so 4x plus 3, we know now that y is also 3. Will give you 5. So 4x plus 3 times 3, which is 9, gives us 5. Then we take 9 from both sides, and we get that 4x is equal to negative 4. Finally, we can divide both sides by 4, and we get that x is equal to negative 1. So my solutions are y equals 3 and x equals negative 1. Now you know I love to check my work. So how can we check this? All right, well, we do have another equation. We can check that our x and y work for that other equation. And if they do, then we've found the right solutions. All right, so our other equation was negative 4x plus 10y equals 34. We got that x is negative 1 plus 10. We got that y is 3. And that does give us 34. Okay, so we're going to do another elimination question, but this one looks just so much harder because if we take our equations and we add them, we're not going to eliminate the x's, we're not going to eliminate the y's. If we subtract them from each other, we're still not going to eliminate anything. So how do we work with this? Well, what we're going to do is we're going to try to get two equivalent equations that does have something that can be eliminated. So the first step in doing this is to find a common multiple for either the x's or the y's, up to you. Now I choose to find my common multiple for the x's because we have smaller numbers here. If I chose the y's, I would have to work with a larger common multiple, and I want to work with something nice and reasonably small. Alright, so my common multiple that I found for my x's is 10x. So ultimately we're going to try to get both of these equations to have a 10x that we can end up eliminating. Alright, so let's do it. For the first equation to get a 10x, we need to take that equation and multiply the entire equation by 5. Because if we multiply 2 by 5, 2x by 5, we'll get our 10x, and that's what we want. So our first equation turns to 10x minus 35y equals 50. Alright, so again, all I did there was take that whole equation and multiply it by 5 so we could get 10x here. Now, time to take our second equation and multiply it by something that will give us the 10x that we want. Alright, so in order to get 10x there, we would have to multiply our 5x by 2. So when we multiply 5x by 2, we do get 10x. That's what we need, but again, we have to multiply everything by 2. So we get 10x minus 12y is equal to 4. So now this is looking like something we know how to work with for elimination. So at this point, we can take our equations and we can subtract them from each other. That will eliminate the 10x because 10x minus 10x is 0, so it goes away. And or negative 35y minus negative 12 should give you negative 23y, and 50 minus 4 gives us 46. Almost there. Now we can divide both sides by negative 23, and we get that y is equal to, and that's we're dividing by negative 23, y is equal to negative 2. All right, but that's only one of our solutions. Time to find the other. And I'm going to work with this equation, but it doesn't matter which one you work with. Both of them should work or help to give you our x value. So our equation says that 5x minus 6y is equal to 2. 5x, we don't know what x is yet, minus 6 times negative 2 is equal to 2. So 5x plus 12, negative negative, equals 2. Now we can subtract 12 from both sides. And we get that 5x, let's switch colors here, 5x is equal to negative 10. So therefore, dividing 5 by both sides, we get that x is also equal to negative 2. And I'd go about and check that answer, but you can do that on your own. You can check by plugging in to the other equation and making sure it works out.